this video we're going to see how we should solve this integral 0 to pi over 2 of 1 over ith root of tan x. First, I'm going to write this integral as exponential form. So it's going to be tan of x to the power of 1 over I dx. And if I use the identity tan x equals to sine x divided by x, I'm going to get the integral from 0 to pi over 2 of 1 over sine x to the power of 1 over I cosine x to the power of negative 1 over I dx. So this is the form that I'm going to have it here. Now I can move them up. If I have to move them up outside, I'm going to have cosine x to the power of 1 over I times sine x to the power of negative 1 over I dx. So here there is an interesting similarity to beta function. Beta of mn is 2 multiplied by the integral from 0 to pi over 2 of sine x to the power of 2m minus 1 cosine x to the power of 2m minus 1 dx. And I can say that I want to make 2m minus 1 equal to negative 1 over I. Thus 2m is going to be 1 minus 1 over I. I can define 2m to be 1 plus I squared over I. If you multiply both sides by I, you're going to see y. And I can say 2m is I over I plus negative 1 over I. 2m therefore is I minus 1 over I times I over I. And it's going to be I squared minus I over negative 1, which is negative 1 minus I over negative 1, which is 1 plus I. This is my 2m, so let me create more space for my future work that I'm going to do here. 2m is 1 plus I, and m is half plus I over 2. So for the other thing here, 2n minus 1 is, I'm going to let it be equal to 1 over I. 2n is going to be 1 plus 1 over I. And n is going to be half minus I over 2. If you do all the calculations here, you're going to see why this thing is true here. You just have to multiply it by I squared over I. Here's the thing that we did here with 2m. So this is n and this is n. I'm going to write it here. m is going to be half plus I over 2, and then it's going to be half minus I over 2. So now I can plug it in for the beta function, which is going to be half beta of half plus I over 2 half minus I over 2. So this is our thing here. Now I can write it in terms of gamma function, gamma of half plus I over 2, gamma of half minus I over 2 over gamma of half plus I over 2 plus half minus I over 2, which is gamma of 1, which gamma of 1 is 1. So it's going to be half times gamma of half plus I over 2, gamma of half minus I over 2. Now, here, what I can do, I want to have it in a state that I want for myself. going to say 1 minus half plus I over 2 here. And now here, I can use the identity of gamma of x times 1 minus x is pi over sine pi x. And using this identity, I am going to get the integral to be half multiplied by pi over sine pi half plus I over 2. And if I use the compound angle formula, I'm going to get half times pi over cosine pi I over 2. Now remember, cosine z of a complex number is e to the I z plus e to the negative I z over 2. Now I'm going to place I pi over 2. This is going to be the e to the I squared pi or I over 2 plus e to the negative I squared pi over 2 over 2. So let me create more space again here. So if I plug it in here, my I is going to be pi over 2 times e to the negative pi over 2 plus e to the pi over 2. These two are going to go away, which is pi over 1 over e to the pi over 2 plus e to the pi over 2. Now the simplest form here, fully simplified here, is pi e to the pi over 2 divided by e to the pi plus 1, which is exactly equal to the integral from 0 to pi over 2 of 1 over ith root of tan x dx. And that is how we derive this complex integral here. Thank you for watching my video. If you liked it, please like and subscribe, and I'll see you next video.